Our planet needs our help. We rely on fossil fuels like coal and oil. These fuels pollute our air and water. They are also running out. We need a new way to power our world. We need clean, sustainable energy. Renewable energy sources hold the key. These sources, like solar and wind power, replenish naturally. Among them, biofuels stand out. Biofuels offer a promising solution for a greener future. They are derived from organic matter, making them a renewable and sustainable alternative to traditional fossil fuels. Biofuels are fuels made from plants or organic waste. They can power vehicles and generate electricity. Common types of biofuels include ethanol, biodiesel, and biogas. Ethanol is a biofuel made from crops like corn and sugarcane. It is often blended with gasoline. Biodiesel is made from vegetable oils or animal fats. It can be used in diesel engines. Biogas comes from the breakdown of organic matter. This gas can be used for cooking and heating. Different biofuels have different production processes. Ethanol production involves fermentation. First, the starch in crops like corn is converted to sugar. Yeast then ferments this sugar into ethanol. Biodiesel production uses a process called transesterification. Here, vegetable oils or animal fats react with an alcohol. This process produces biodiesel and glycerin, a valuable byproduct. Biogas, on the other hand, is produced through anaerobic digestion, where microorganisms break down organic waste in the absence of oxygen. Biofuels offer several advantages over fossil fuels. Firstly, they are renewable. Unlike fossil fuels that take millions of years to form, biofuels can be replenished relatively quickly by growing more crops or using waste materials. Secondly, biofuels are generally considered carbon neutral. While burning biofuels does release carbon dioxide, the process of growing the plants or algae used to make them absorbs carbon dioxide from the atmosphere. This makes biofuels a more environmentally friendly option. Section 5. Challenges on the road to sustainability. Despite their potential, biofuels also present some challenges. One major concern is land use. Growing crops for biofuels can compete with food production. This competition for land can lead to deforestation and habitat loss if not managed sustainably. Another challenge is cost. Producing biofuels on a large scale can be expensive. The technology involved in converting biomass into fuel is constantly improving, but it can still be costly. Section 6. Food or fuel, a delicate balance. In recent years, the debate over whether to use valuable agricultural land for food production or for growing biofuel crops has intensified. This issue is particularly pressing as the global population continues to grow and the demand for both food and energy increases. The use of food crops for biofuel production has sparked the food versus fuel debate. On one hand, biofuels offer a renewable source of energy that can help reduce our reliance on fossil fuels and decrease greenhouse gas emissions. On the other hand, using food crops for fuel can have significant implications for food security and prices. Critics argue that diverting food crops to produce fuel can drive up food prices and lead to food shortages. This is especially concerning in regions where people are already struggling to afford basic necessities. When food prices rise, it can lead to increased hunger and malnutrition, particularly among the most vulnerable populations. This is a valid concern, especially in developing countries where food security is already a challenge. In these areas, the competition between food and fuel can exacerbate existing issues, making it even harder for people to access the food they need to survive. The balance between producing biofuels and ensuring food security is delicate and requires careful consideration. However, it is important to note that not all biofuels are created equal in this regard. There are different generations of biofuels, each with its own set of advantages and disadvantages. Understanding these differences is crucial for making informed decisions about biofuel production and its impact on food security. First-generation biofuels, like those made from corn or sugarcane, do compete directly with food crops. These biofuels are produced from edible parts of plants, which means that the land used to grow these crops is not available for food production. This direct competition can lead to higher food prices and reduced availability of food. However, second-generation biofuels, which are made from non-food sources like agricultural residues and waste materials, offer a more sustainable alternative. These biofuels do not compete directly with food crops, as they are produced from parts of plants that are not used for food. This makes them a more environmentally friendly and socially responsible option for biofuel production. Additionally, research is ongoing into third-generation biofuels, which are derived from algae and other advanced sources. These biofuels have the potential to provide even greater benefits, as they can be produced on non-arable land and have a higher yield per acre compared to traditional biofuel crops. As technology advances, these innovative solutions could help us achieve a more sustainable balance between food and fuel production. Section 7. Next-generation biofuels beyond food. Second-generation biofuels hold great promise for the future of sustainable energy. Unlike first-generation biofuels, which are derived from food crops like corn and sugarcane, second-generation biofuels are produced from non-food sources. This makes them a more sustainable and ethical choice, as they do not compete with food production and can help to reduce greenhouse gas emissions. These biofuels are made from non-food sources, such as agricultural waste, which includes crop residues like straw and husks. By using these materials, we can make use of resources that would otherwise go to waste. Other sources include wood chips from forestry residues and even algae, which can be cultivated in ponds or tanks. Algae, in particular, are a fascinating source of biofuel because they can grow rapidly and in a variety of environments. By utilizing these waste materials, second-generation biofuels avoid competing with food production. This is crucial in a world where food security is a growing concern. Additionally, the use of waste materials helps to manage waste streams, turning potential pollutants into valuable resources. Effective waste management is a key benefit of second-generation biofuels. By converting agricultural and forestry residues into energy, we can reduce the amount of waste that ends up in landfills or is burned, which in turn reduces air pollution and greenhouse gas emissions. Algae, in particular, have gained attention as a promising source of biofuel. They can be grown in a variety of environments, including wastewater and saltwater, which means they do not require arable land or fresh water that could be used for food production. They can grow rapidly in a variety of environments, including wastewater and saltwater, and they have a high oil content that can be converted into biodiesel. This makes algae a highly efficient and sustainable source of biofuel. The high oil content of algae is particularly advantageous for biodiesel production. This oil can be extracted and processed into biodiesel, which can be used as a renewable alternative to fossil fuels. As research and technology continue to advance, the potential for algae-based biofuels to contribute to a sustainable energy future becomes increasingly promising. Section 8. Biofuels, a global perspective. The development and adoption of biofuels vary across the globe. Some countries, like Brazil, have successfully integrated biofuels into their energy mix. Brazil is a major producer and consumer of ethanol thanks to its vast sugarcane plantations. Other countries are also exploring the potential of biofuels. For instance, in Southeast Asia, countries like Indonesia and Malaysia are looking into palm oil as a feedstock for biodiesel. However, sustainable production practices are crucial to prevent deforestation and habitat loss associated with palm oil cultivation. Section 9. A sustainable future with biofuels. Biofuels have the potential to play a significant role in creating a more sustainable future. Derived from organic materials such as plant and animal waste, biofuels offer a renewable alternative to traditional fossil fuels. They can be produced from a variety of sources, including crops like corn, sugarcane, and even algae. This versatility makes biofuels a promising solution for reducing greenhouse gas emissions and decreasing our dependence on non-renewable energy sources. By reducing our reliance on fossil fuels, we can mitigate the impacts of climate change and improve air quality. Fossil fuels, when burned, release a significant amount of carbon dioxide and other pollutants into the atmosphere, contributing to global warming and health issues. In contrast, biofuels burn cleaner, producing fewer emissions and helping to create a healthier environment. This shift not only benefits the planet but also enhances the quality of life for communities around the world. However, a sustainable biofuel industry requires careful planning and responsible practices. It's essential to balance the production of biofuels with the need to protect natural ecosystems and ensure that agricultural practices do not harm the environment. This involves adopting sustainable farming techniques such as crop rotation and the use of organic fertilizers to maintain soil health and biodiversity. We need to ensure that biofuel production does not come at the expense of food security or environmental conservation. The land used for growing biofuel crops should not compete with land needed for food production. Additionally, it's crucial to protect forests and other natural habitats from being converted into biofuel plantations. This balance is vital for maintaining the health of our planet and ensuring that future generations have access to both energy and food resources. By investing in research and development, we can discover new and more efficient ways to produce biofuels. Innovations in biotechnology and agricultural practices can lead to higher yields and lower environmental impacts. For instance, advancements in genetic engineering could result in crops that require less water and are more resistant to pests, further enhancing the sustainability of biofuel production. Promoting sustainable land use practices is also crucial. This includes integrating biofuel crops into existing agricultural systems in a way that supports soil health and biodiversity. Techniques such as agroforestry, where trees and crops are grown together, can provide multiple benefits, including carbon sequestration, habitat for wildlife, and improved resilience to climate change. Supporting policies that encourage responsible biofuel production is essential. Governments and international organizations play a key role in setting standards and providing incentives for sustainable practices. Policies that promote research, provide subsidies for sustainable biofuel production, and enforce environmental regulations can drive the industry towards a more sustainable future. By harnessing the power of biofuels, we can create a cleaner, greener, and more sustainable future for all. This transition requires a collective effort from scientists, farmers, policymakers, and consumers. Together, we can reduce our carbon footprint, protect our natural resources, and ensure a healthier planet for generations to come.